Crossed electric and magnetic field velocity selector. So crossed electric and magnetic field. In the figure you can see that crossed electric and magnetic field means the electric field and magnetic fields are perpendicular to each other, they are crossed. And velocity selector. The velocity selector is a device used to select a charged particles of a particular velocity out of a beam of charged particles having different velocities. Okay, to understand that, I have a diagram over here. You can see the diagram. So here you can see the two slits. So this is one slit, S1, and this is one more slit, S2. You can see that. So here there are beam of charged particles. There are many beam of charged particles which can go through the slit S1. They can go pass through the slit S1, and we can receive those charges somewhere here through the slit S2. But between these two slits you can see there is a crossed fields. That means there is a magnetic field here. These magnetic fields are perpendicular to the plane of the paper and inwards. So this into mark represents the magnetic field is into the plane of the paper directed inward. So magnetic field it is. I will write B. And electric field also you can see these are the plates, positive plate and negative plate, that also produces electric field, and that electric field is from positive plate to the negative plate downward, like this it is there. Okay, now in such a field a charged particle is moving. Suppose I will consider only one charged particle. This is one charged particle which is coming. It is moving with a velocity v. It is moving with a velocity v. So the particle is moving with velocity v. It experiences a magnetic force as well as electric force. In total, it experiences a Lorentz force. Lorentz force means it experiences both electric force and magnetic force. Now let us concentrate on only magnetic force. So when a charged particle enters with certain velocity v, so the velocity direction is like this, and magnetic field direction is inward into the board or into the plane of the paper. So you have to use the right hand rule. If you use the right hand rule, you have to curl your finger from V towards B. The thumb points in the upward direction. So the magnetic field will be upward. And what about electric force? So when a charged particle comes here, it experiences electric force. That electric force will be downward. Why? Because this positive charge is coming. Whenever this positive charge comes here, this will be repelled by this positive plate and attracted by negative plate. As a result, it experiences downward force. Downward force. Right. If electric force is more, the charged particles, whatever the charged particles are coming here, will move downwards. If magnetic force is more on that, then the charged particles go somewhere here, upward. But if the charged particle, particular charged particle, is moving and the force acting on that particular charged particle, the upward force and downward force both are equal, then the charged particle moves straight. and that particular charged particle can be received after the slit 2. So there are many charged particles are coming here into the slit S1. Out of this beam, only the charged particle having particular velocity can be received. So which kind of charged particles we are receiving here? The charged particle having upward force, that is magnetic force, and downward force, that is electric force, both should balance. Then such a particle will not deflect upward or downward, will move straight and will be received. So this is the condition of velocity selector. So velocity of particular velocity of charged particle. So magnetic force. What is the magnetic force formula? That is QVB. And electric force formula, this is QE, right? Then we can cancel the similar terms Q and Q, and you will left with V is equal to E divided by B. And this velocity of a charged particle out of a beam will move straight without any deflection. That means any of the charged particle having this particular velocity v is equal to E by B will not experience any upward or downward force, will move straight, or in other words, it experiences equal force on upward and downside, and as a result it moves straight.